Good morning, good afternoon, good evening, whatever time it is where you're watching this video. In this video, we're going to be taking a look at a problem that I've selected from a mathematics admissions test paper, and it's the 2023 MAT paper, and it's question 2 that we're going to be looking at. So this is one of the more structured problems on the MAT. Really nice little problem. Not particularly difficult in many ways. Compared to some of the other problems that I've seen on MATs, this was a little bit easier, although the last part you had to maybe think a little bit more carefully than in the previous parts. Okay, so let's get into things. What's the... hopefully, if I remember, then I'll put the question up on the screen somewhere along the bottom. I don't know which side yet. And I'll also leave a link in the description to this video so you can download the paper yourself. And you can have a look at some of the other questions as well. Okay, so question number 2. For n a positive whole number and for x not equal to 0, let Pnx equal x to the power of n plus x to the power of minus n. Okay, which I prefer to write as x to the power of n plus 1 over x to the power of n. That's just personal preference. And then, okay, part 1. Sketch the graph of y equals p1x and label any turning points on your sketch. Okay, so first of all, what is the equation of p1x? It's x plus 1 over x. Okay, so the way that I drew this was the following. And when it comes to drawing graphs of functions, you've potentially got to use a variety of techniques. And it really depends on the particular features of that particular function. Okay, so what I'm about to do now, when I give you an idea about how I went about sketching the graph of this function, it's just what I did in this particular case, based on what I saw. And also, yeah, I've kind of come across this before, so I had a bit of an idea about what it was going to look like anyway. But nevertheless, it's this is a fairly common technique, I guess, that because we've got a sum of x and 1 over x, I know what x looks like, and I know what 1 over x looks like. So sometimes considering those separately and trying to put them together can give you an idea what the overall graph is going to look like. It doesn't always work like that, but it can go a long way. So y equals x looks something like this. 1 over x looks something like this. And if you do struggle to draw graphs of functions, then I'd get that sorted for the MAT. Okay, so what I expect then is that x plus 1 over x is going to be the sum of the values of this and this. Okay, so notice that here the values of y equals x are very small. So x plus 1 over x is going to basically look like 1 over x. Then as we get to this point here, which is at x equals 1, by the way, the overall value here is going to be 2. So it's going to look something like that. And then over here, the value of 1 over x gets very small. So therefore, the graph is going to look more and more like y equals x. Okay, so we've got these kind of asymptotes in here. And similarly down here, we get a graph that looks like that. Label the turning points. Well, that's easy. It's differentiation, right? So dp1 by dx is going to be 1 minus 1 over x squared. So when this is equal to 0, then we get 1 over x squared equals 1, x squared equals 1, and therefore x equals plus minus 1. When x equals 1, we get y equals 2, or p1 of 1 is equal to 2, and minus 1 minus 2. Okay, And that's it. That's my graph. Okay, it's as simple as that. It's up to you if you wanted to leave, if you did use this approach, if you wanted to leave these kind of guidelines in to give some idea how you've arrived at your decision. I personally would leave those in. It's up to you though, because what your examiners are really going to be interested in on the MAT is how you've arrived at your results. So when they ask you to sketch the graph of y equals P1x, what they're really wanting to know is how do you arrive at your conclusion that this is what the graph of P1x kind of looks like, right? Not just because you might know this off the top of your head. If you do, then you do. Okay, you can just draw it. But really, you need to be giving some justification. Even if you do know this off the top of your head, how would you, if you didn't know, how would you justify it? That's what you're trying to communicate. Always remember that with the MAT. It's not about just getting the answer. It's about how do you arrive there. There'll be much more weight attached to a good justification, but maybe you fall at the last hurdle and you don't make the right conclusion, but you've got a very good, well-developed idea. This will count for more than kind of a patchy idea, even if you arrive at the correct conclusion, because the overall thing's just, if it's too clunky or whatever, it doesn't really, what you're saying, how you've developed your idea doesn't really point towards the conclusion that you've made. All these kinds of things, it really it's quite jarring, and it can work against you potentially. Okay, now I'm not an examiner for the MAT, so I don't know exactly what they're looking for. I'm just speculating to a certain extent about what I think they're going to be interested in. Okay, so part 2, show that. So let's get rid of this because we don't actually need this now. As is often the case with these more structured problems, the first part, maybe the first couple of parts, are just kind of gently easing you into the problem, and then it gets a bit more serious. Okay, so P2x, show that P2x is equal to P1x squared minus 2. So we understand this as meaning P1x times P1x, not P1 of x squared or anything like that. So, okay, this is easy. This is straightforward. P2x is x squared plus 1 over x squared, which is x plus 1 over x squared minus 2. Okay, expand this out, see what you get. You'll get this, which is equal to P1x squared minus 2. Okay, easy, straightforward. It's only 1 mark anyway. Okay, and then find an expression for P3x in terms of P1x. Similar kind of thing, to be honest with you. Let's have a look. P3x, which is x cubed plus 1 over x cubed. So it might be worth noting that now you've kind of got a bit of an idea about where things are going. You want to express this in terms of P1x. My guess would be to have a look at what happens when you cube this thing, which is P1x. So you get x cubed plus 3x plus 3 over x plus 1 over x cubed, which of course is equal to x cubed plus 1 over x cubed plus 3x plus 1 over x. So therefore, and yes, I would show this calculation in my working in the exam. So I've done it to one side here, but this is effectively part of my solution. Oh, rubbing it off, aren't I? There we go. So this is going to be equal to x plus 1 over x cubed minus 3 times x plus 1 over x, which is P1x cubed minus 3 P1x. Okay, no problems so far. Okay, by the way, guys, if you do find these videos useful, then please hit the subscribe button and hit the like button. And if you know anybody else that's preparing for A-level maths exams, STEP exams, MAT, anything like that, please let them know about these videos and hopefully they can get some use out of them as well. Cheers. Okay, so on to the next part. Find all real solutions x to this equation. I should put my glasses on, really, shouldn't I? So it's x to the power of 4 plus x cubed minus 10x squared plus x plus 1 equals 0. Okay. I've rubbed it off now. So what was it? P2x is equal to P1x, because we are going to need these. And P3x is P1x cubed minus 3P1x. I might get lazy at some point and just write P1 instead of P1x all the time. Okay, so we've got the equation x to the power of 4 plus x cubed, minus 10x squared plus x plus 1 equals 0. Okay, so we're told right at the beginning of this problem, x is not equal to 0. So that allows me to divide through by x squared. And I get x squared plus x minus 10 plus 1 over x plus 1 over x squared equals 0. And therefore, x squared plus 1 over x squared plus x plus 1 over x minus 10 equals 0. Would you believe it? That's P2x, which is also P1x squared minus 2. This is P1x minus 10 equals 0. So I get P1 squared plus P1 minus 12 equals 0. So P1 plus 4, it's just a quadratic, minus 3 equals 0. So P1 equals minus 4, or P1 equals 3. We're not done yet, because remember P1 was x plus 1 over x. So that means that x plus 1 over x equals minus 4, or x plus 1 over x equals 3. This is the quadratic. This is equivalent to the quadratic x squared plus 4x plus 1 equals 0. This is equivalent to the quadratic x squared minus 3x plus 1 equals 0. The solutions to this quadratic equation, minus 4 plus minus the square root of 16 minus 4 over 2. So x equals minus 2 plus minus, that'd be root 3. And this x equals 3 plus minus the square root of 9 minus 4 over 2, which is 3 plus minus root 5 over 2. As we would kind of expect, because it's a quartic, we would expect potentially 4 solutions. Okay, if we're getting more than 4 solutions, we've definitely done something wrong. But we could get less. We could get fewer than 4 solutions if we've got imaginary solutions. But it does specifically ask for real solutions. But we get 4 real solutions, which is exactly the right number. Now, I did check, by the way, you don't have to do this in your exam. Bear in mind, you don't have a calculator, as far as I know, on the MAT, unless things have changed. I did actually check this. I was quite confident with this, but I just wanted to double check this one. So I did check it, and it does well. I checked 3 plus root 5 over 2. And if that works, then the other one's going to work as well. And it did work. So it took me a couple of minutes just to check it. You don't have to do it, but it's really if you want to make sure that you've got the right answers, that's all. And yes, I did check it without a calculator. Okay, so that's that part done. So we're on to the final part now. So we're absolutely blazing through this problem. No difficulties so far. The next one, there's something to catch you out potentially. It's similar to the previous one, except we need to solve the equation x to the power of 7 plus 2x to the power of 6 minus 5x to the power of 5 minus 7x to the 4th plus 7x cubed plus 5 minus 2 minus 1. It's 5x squared minus 2x minus 1 equals 0. Okay, so if you're anything like me, then what you initially thought to do was basically the same kind of thing that happened in the previous question, where in the previous one we divided through by x squared. You might try something like that here. It doesn't work though. Okay, it doesn't quite work. First of all, there's not really a suitable value to divide through by. But second of all, notice that you've got the sign differences. You've got some sign differences going on in here. So that creates a bit of a problem. But with a couple of minutes of thinking, it occurs to you, this is a polynomial. Maybe I can use the factor theorem. And it turns out that if you try x equals 1, you get that this is equal to 0. X equals 1 is a solution. So by factor theorem, x minus 1 is a factor of, what shall I call it? This thing here, I'll just call star. So x minus 1 is a factor of star. So then you've either got to do maybe algebraic long division, or if you hate doing algebraic long division like I do, then you can just use kind of comparing the coefficients. So if I've got x minus 1 here, I need x to the power of 6 here. By the way, I would probably say here that this x minus 1 is a factor of star by factor theorem, so that it's fully justified how I'm coming to this conclusion. Always be as explicit as you can be on your MAT exam about what you've done, why you've done it. Okay, obviously you don't need to go into an anal level of detail, but you do need to make it clear how you're arriving at your conclusion. So if you've used factor theorem, nobody knows about it unless you say that you've used factor theorem. Okay, you've got to make it clear. So going back to this then, if I were to expand this out, I'd get minus x squared, so I need, what, plus 3x to the power of 5. If I were to expand this out, I'd get minus 3x to the power of 5, so I need a minus 2x to the 4th. If I were to expand this out, I lost track now of what I was doing. I'd get 2x to the 4th, so I need a minus 9x cubed. If I were to expand that out, I'd get a 9x cubed, so I need a minus 2x squared. I'd get 2x squared, so I need a plus 3x. There I'd get a minus 3x, so I need a plus x. A plus 1, and that does me. Okay, so that saves me the business of doing algebraic division. I hate doing algebraic long division. Such a bore. Okay, but this is good, because now if this is equal to 0, that means that x equals 1 or this is equal to 0. So I need the equation x squared plus 3x to the 5 minus 2x4 minus 9x cubed minus 2x squared plus 3x plus 1 equals 0. And now I can do basically what I did in the previous part. Divide, or similar thing. Divide through by x cubed, so I get x cubed plus 3x squared minus 2x minus 9 minus 2 over x plus 3 over x squared plus 1 over x cubed, which gives me x cubed plus 1 over x cubed plus 3x squared plus 1 over x squared minus 2x plus 1 over x minus 9 equals 0. And then I'm actually not going to go through it step by step necessarily, but substitute the expressions that you've got here, because notice that this is P3x. Write it in terms of P1x. This is P2x. This is P1x. So you'll get P1 cubed minus 3P1 plus P1 squared minus 2 minus 2P1 minus 9 equals 0, which gives P1 cubed minus plus P1 squared minus 5P1 minus 9 equals 0. So it's a cubic. Is that right? I think I've made a mistake somewhere. So it'd be a P1 squared somewhere. It should be 3 P1s. That's 3P1. Yeah, it should be 3P1 squared here minus 6. Yeah, I knew I'd made a mistake. Minus 15 and plus 3P1 squared minus 5P1 minus 15. Okay. Okay, I'm not gonna. How far should I? No, I may as well just carry on now, hadn't I? So let me clear a little bit of space here. So we've got a cubic, P1 cubed plus 3P1 squared minus 5P1 minus 15 equals 0. Again, it's kind of a factor theorem jobby here. So if you try P1 equals, you just got to hunt around a little bit. So I don't know what it was that eventually, I tried 1 and minus 1, but then something clicked and minus 3. Because I think I saw the factor of 3 here and the factor of 3 and the 15. It kind of suggested that 3 was going to be involved. So I just tried P1. It wasn't something that was forced to work. It was just something that I noticed that kind of prompted me to do something that happened to work. It's just, you get lucky like that sometimes. So try P1 equals minus 3. That's a factor of this. So, sorry, P1 plus 3 is going to be a factor. So then you get P1 squared. I'm going to look at my minus 5 equals 0. So therefore, we've got x equals 1 is a solution. We've also got P1 equals minus 3. P1 equals the square root of 5 and P1 equals minus the square root of 5. Now, bearing in mind that P1 is x plus 1 over x, we get x plus 1 over x equals minus 3, x plus 1 over x equals the square root of 5, or x plus 1 over x equals minus the square root of 5. And this leads to the solutions, and I'm not going to go through step by step exactly. All it is solving quadratics. For this one, there's no real solutions in that particular case. Have I made a mistake here? Sorry. No, that's right. Sorry, I'm just... No, you do get solutions in this. So in this case, you get that x is equal to minus 3 plus minus the square root of 5 over 2. In this case, you get the solutions x equals, what do you get? Square root of 5. Square root of 5 plus minus 1 over 2. And in this case, you get minus the square root of 5 plus minus 1 over 2. We've already got this solution, x equals 1 up here. So that gives us a total number of 7 solutions, which kind of fits the bill really, right? We've got a x to the power of 7. For some reason I thought there was, I must be thinking about a different problem, but for some reason I thought there was one of these that gave no real solutions. And that's it, okay? We've got all our solutions to this equation. So this is very common with MAT problems where you're kind of guided through. It's very similar to STEP, but just on the intensity is not as great, where you're kind of guided through a problem, and then the final part is where you've got to go through the whole thing yourself, effectively, on your own, unguided. But also there's a couple of extra little twists included for you to deal with. So it's not exactly just follow step by step what you've just seen. There's a bit more to it. Okay, so that brings us to the end of this problem. It brings us to the end of this video just about. So hit the subscribe button, hit the like button. If you've got any ideas about anything that you would like to see videos on relating to particularly A-level maths, A-level further maths, STEP, MAT, or anything else maths related, let me know. And I'd love to make a video on it if I can. But leave your ideas in the comments section, and I'll see you in the next video. Thanks very much for watching.